Hi everybody, we're in lab about to determine the acceleration due to gravity for an object in free fall. We're going to use a device called a photo gate, which is a gate because something passes through it, and photo because it's a light beam. So one end of that U-shaped object has a light beam coming out of it and the other end has an electric eye. So the computer can detect if the light beam is blocked or unblocked. And our interface, the LabQuest Mini here, is going to communicate with Vernier. So I'm going to double click on my applications on the computer, and you'll be doing this, I hope, soon when you come back to class. And I'm going to choose Logger Pro, which is our software. And within that software, I'm going to go File, Open, to choose a lab called Picket Fence Freefall. Oops, sorry, I want to open. And this is going to be called Physics with Vernier. So I look down here in Physics with Vernier and I find Lab 03, Picket Fence Freefall. Right there. Okay, so when it opens, what I have is a question asking me, do I really want to connect my interface? So I say, yes, let's connect that thing. And now the PhotoGate and the computer can communicate with each other. And what I see here is really important. It's two graphs on one screen. The upper graph, it says distance and time. So in other words, that's a position versus time graph. The lower graph says velocity and time. So it's a velocity versus time graph. I'm going to get two graphs at once every time I drop through this object, which is called a picket fence. A picket fence ordinarily looks like this. That is, there's a blocked area with a fence board, and then there's a gap between them. Most of us have privacy fences in San Antonio, but you can find these in King William. And what we're going to do is drop the picket fence through the photo gate. And when we drop the picket fence through the photo gate, the light beam will become blocked every time one of the black sections goes through, and unblocked every time the clear section goes through. And so what we want to do is let this thing fall. And if it's accelerating, it's going to fall faster and faster and faster. And as it does that, the amount of time that things will be blocked will become shorter and shorter.
When?
When?
Oh, hit the side of the...
It's probably good, but go ahead.
Here,
Whenever
I'll
you're
find
ready.
it
Nice. So now that we've dropped the picket fence, how do we get some useful information out of this? I'm going to take my cursor to the toolbar at the top, and I'm going to choose Analyze, like you will when you're in class, over and over again. And I'm going to look for a linear fit. I want a line. I want to know what the slope of these graphs are. So when I choose linear fit, I get this beautiful screen showing me two graphs, and now it's up to me to decide which one of these graphs has the meaning that I need. Is it the position versus time graph, which they've called distance versus time? Or is it the velocity versus time graph that you see on the lower half of the screen? Inside that window is all the statistics information. So there's the linear fit for the distance versus time graph. And here is the linear fit for the velocity versus time graph. You'll notice there's no y in that y is equal to mx plus b. This graph is about velocity and time, so it has variables of v and t. This one's about position and time, so it has variables of d and t. It's your job to decide where you can find the acceleration due to gravity on these graphs.